I'll be okay, I think.
I guess we have all the guests among us, and are we good to go?
I think so, yeah. Yeah, I guess whenever
Yes.
you'd like to start.
Yes, sir. So it's not that we just use technology, we live technology. It resides almost in every nook and corner in not one, but several forms, and every now and then it beams back at us in hope of revered recognition. So, to celebrate its euphoric existence, advancement, and innovation, I, Bhavya Malhotra, welcome you all in this sublime morning as we raise the curtains to let the luminescence of Technex'22 strike our minds. Asia's oldest techno management fest, Technex, is the annual flagship event organized by IIT BHU Varanasi that receives a footfall of over 20,000 students with budding and fruitful minds seeking to learn new things from across 400 colleges in India every year. With the theme Simulating Reality, Technex is here to galvanize the minds and broaden one's horizons. Today, in this inaugural ceremony, we have among us Professor Jeffrey David Ullman, Dr. Shailesh Kumar, Professor Pramod Kumar Jain, Director IIT BHU, Professor LP Singh, Dean of Student Affairs IIT BHU, Professor RK Upadhyay, Counselor of Science and Technology Council IIT BHU, and Mr. Ishwar Vak Dinesh Reddy, General Secretary, Science and Technology Council IIT BHU. So before we commence this new chapter of Technex, let's replenish ourselves with the melodious symphony of the Kulgeet, a song that stands as our definition. I would request the host to play it. Aishwarya, could you share your screen and play the song? These technical glitches and delays are inevitable in online sphere, and
Okay.
yeah.
Can you sing it for us?
Sorry, sir.
Can you sing it? The song.
Oh, I don't have that melodious voice. So yeah.
Okay.
Well, I'll try sharing my screen. Please let me know if it's audible and visible or not. Just a second. Is my screen visible?
Well, I'm seeing something. It's a young woman.
Yeah, right. I'll play it.
Yes, yeah.
मधुर मनोहर अतीव सुंदर ये सर्ववेद्या की राजधानी मधुर मनोहर अतीव सुंदर ये सर्ववेद्या की राजधानी राजधानी ये तीनों लोकों से न्यारी काशी सुज्ञान धर्म और सत्य राशि बसी है गंगा के रम्य तट पर ये सर्व विद्या की राजधानी राजधानी मधुर मनोहर अतीव सुंदर ये सर्व विद्या की राजधानी राजधानी नई नहीं है ये ईंट पत्थर है विश्वकर्मा का कार्य सुंदर रचे है विद्या के भव्य मंदिर ये सर्व सृष्टि की राजधानी राजधानी मधुर मनोहर अतीव सुंदर ये सर्व विद्या की राजधानी राजधानी ये मालवीय जी की देश भक्ति ये उनका साहस ये उनकी शक्ति प्रकट हुई है नवीन होकर ये कर्मवीरों की राजधानी राजधानी मधुर मनोहर अतीव सुंदर ये सर्व विद्या की राजधानी राजधानी मधुर मनोहर अतीव सुंदर ये सर्व विद्या की राजधानी राजधानी
Very nice.
After filling the air with revitalizing notes of Kulgeet, we are all set to step into this grid of technological amazement, Technex'22. It's an honor for us to have the eminent presence of Professor Jeffrey David Ullman and Dr. Shailesh Kumar as our prominent guests for today's Think Talk. Professor Ullman is an American computer scientist and the Stanford W. Asherman Professor of Engineering Emeritus at Stanford University. Having written 16 well-acclaimed books on compilers, theory of computation, data structures, and databases, he is counted amongst the dignitaries of the highest distinction in computer science and consequently received the 2020 Turing Award. We all have grown up reading your books, sir.
I am glad to hear that. Thank you very much. It's
Yes, sir.
probably way overestimate of my abilities, but sure.
Thank you, sir. So we also have among us Madam Dr. Kumar, an alumnus of IIT BHU CSC 95, who is currently the Chief Data Scientist at Reliance Geo, mentor and program chair for the AI and DS program at the Geo Institute of Eminence, and visiting faculty of machine learning at Indian School of Business. Being recognized as one of the top 10 data scientists in India in 2015, he had also served as distinguished scientist at Ola, principal scientist at Microsoft Bing, senior scientist at Yahoo Labs, co-founded Thirdly, and principal scientist at Fair Isaac Research. We welcome you, sir.
Thank you. It's a pleasure to be here. Thank you.
Yes, sir. We ecstatically welcome you both to the 83rd edition of Technex'. Now, I would like to invite Mr. Dinesh Reddy, the General Secretary of the Science and Technology Council, IIT BHU, to brief us about the legacy of Technex'.
Thank you, Bhavya. Greetings to all the honorable guests, director sir, and all the professors and students present here. I, Dinesh Ishwarvaka, the General Secretary of the Science and Technology Council of IIT BHU Varanasi, courteously welcome you all as you step into this glorious morning with the aim of simulating reality under Technex'22. Technex is Asia's oldest annual techno-management fest that is overseen by the Science and Technology Council of the IIT BHU Gymkhana. The SNTC is a coming together of curious and inquisitive minds working on the latest technologies to foster innovation and contribute to the advancement of our nation and the world. Through its 7 clubs, it aims to not only encourage ideation and innovation, but also to fulfill our responsibilities towards society. An amalgamation of exciting events, informative workshops, eclectic exhibitions, unforgettable shows, and talks by noteworthy personalities, Technex has now become an emotion. With contemporary minds streaming from across the globe, these 3 days of showcase of technological acumen and innovation are truly unforgettable. Despite the tough times, resonating with the theme simulating reality, various teams under Technex have coalesced together under the able guidance of Professor R.K. Upadhyay, and with persistence have set the stage of Technex even in the online environment for the 2nd consecutive year. I would like to thank each and every person who in one way or another played their part in the birth of this 83rd edition. I would like to extend my best wishes to all the participants and organizers and hope that Technex will shine even brighter this year. Thank you and stay Technex'.
Thank you so much, sir. Now, I would like to invite our Honorable Director of IIT BHU Varanasi, Professor Pramod Kumar Jain, to address us all and take the torch of Technex'22 forward with their insights.
A very good morning to all the distinguished chief guests, professors, and students who have joined us today on this auspicious occasion of inaugural function of Technex' 2020. As said by Bhavya and the General Secretary of this event, this is Asia's oldest techno-management fest organized by IIT BHU and its predecessor IIT BHU. And this is the 83rd edition of this event that we are organizing, and that too successfully in last so many years. And we are basically the torch bearers of this illustrious event and the institution which was established by none other than Bharat Ratna Pandit Madan Mohan Malviya ji. Despite we know that we are passing through a difficult phase of coronavirus pandemic, students were away from the campus for the last almost 2 years, and they were missing, in fact, the campus life. And this is an opportunity to them to showcase that they, whatever they have missed in these last 2 years, they will gain all the losses while organizing such events in the campus, wherein they have a chance to interact with the corporate houses, they have a chance to experience some real life problems, and they have a chance, in fact, to manage such a big event in such a short span, and that too in a hybrid mode now. Because in last 2 versions of Technex were in online mode, and this year we are going for a hybrid mode wherein some of the participants are in the campus and many of them will be joining us in online mode. And I think the theme of this year's Technex, that is simulating reality, is very much relevant in today's environment, wherein everybody is talking about AI, machine learning, data science, and like that. And we know that these 3 fields, AI, machine learning, and data science, have applications almost in every domain of today's human being or our lives. And we also have some of the very important projects in the campus wherein we focus on healthcare systems, wherein focus on defense sector, wherein we focus on agriculture, precision agriculture, and communication, and many more, you can say, application areas. So this event, along with the focus on AI, machine learning, and data science, will expose them to all these application areas, and I think they will get good number of participants as well good number of speakers to engage our students and participants on this on this particular topic. And I would also like to give some briefs on, actually I could collect from the students that there are about 22 events they are organizing during these 3 days extravaganza. There would be around 14 workshops, and there would be several competitions where in the participants will showcase their talent, they will showcase their intellectual and their capabilities, and accordingly they will be awarded with some prizes, with some certificates and whatever. And industry has also come forward to support many of these events. In fact, this is one of the major challenge to our students, to engage industry partners to sponsor and to support all such kind of events in India and everywhere. So they could, I think, engage good number of industries to support their events, to support their competitions. And I think Ultratech Cement is one of the major sponsor for them this year. And they, I think, will do a good job. That is, I'm sure. And I would like to extend my best wishes to all the students who are diligently working to bring this fest alive again, and all the participants looking forward to attend the workshops and well-articulated competition. We hope that Technex 2020 to 2022 will reach even greater heights in this edition. With these words, I wish them again to do a good job and to make a good show of this Technex 2022. And I thank all my chief guests, Professor Jeffrey Ullman and Dr. Shailesh, who is our own alumnus, as told by Bhavya. And thank you very much for sparing your valuable time and participating in this inaugural talk. Thank you.
Thank you so much, sir, for enlightening us and for your wholesome wishes for the fest. We really hope that aligning with the Institute's vision, Technex will climb the steps of success this year as well. And now the time has come to dive deep into the intriguing world of computer science with our guest today. How do you feel upon seeing those terrific screens with thousands of lines of codes blinking in neon and getting executed within seconds? Does the idea of building thinking computer systems capture your imagination and engross you completely? Or are you still exploring this wide world with thousands of mind-boggling possibilities? Well, to satiate your curiosity, we have among us Professor Jeffrey David Ullman and Dr. who will be sharing their valuable insights with us today. I would like to invite Professor Ullman and Dr. Kumar to oblige us with their Think Talk.
Okay.
Thank you, Bhavya, and good evening, Professor Ullman. It's a great pleasure to have you here. As Bhavya said, many generations of computer scientists across the world have grown up reading your books, and thank you for putting that effort, because I know that when the field is very young, it's very difficult to create a comprehensive curriculum around it, and the pioneers in the field can do that and help the field catalyze accordingly. So thank you, sir, for your valuable time, and I'm sure all of us will learn a lot from this discussion. And when I look at the theme, which is simulating reality, I think that's exactly what the brain does too, which is, we collect data and we build some models of reality, we simulate reality, and we optimize our actions in that reality. So it's a very perfect theme for where we are in the technological construct, how the technology from calculator to computing to cognitive science is evolving. And I think this is a very beautiful time to have this kind of a discussion with such an eminent scientist, right? So, sir, let me start with our initial discussion around. So, you've been a very celebrated computer scientist, and Obviously all of us have learned a lot from your journey. You've not just been an observer to the journey, you have actually created this journey for computer science. And I just wanted to hear your thoughts on, this. What are some of the great breakthroughs that computer science as a field has done? Every field does a lot of breakthroughs, physics, chemistry, computer science. Any thoughts on this journey, and what were some of the key breakthroughs that you would like to highlight, and how they have helped the field grow?
Okay, this is, of course, a very interesting question. I mean, I could probably just, talk for hours mentioning cool stuff that's gone on. I think you have to pretty much start with the internet. I mean, that is what enables us to be here together in a sense, and of course has just incredibly changed the lives of pretty much everyone in the world. On the other hand, the internet didn't arise from whole cloth. It built on, things from invention of the computer itself to compilers, operating systems, languages, networking, communication systems. All of this was necessary to bring us to where we are today. But okay, let me mention maybe two things that are less obvious, that we tend not to feel the way we sort of feel the internet and smartphones and that kind of thing. So one is the idea of time complexity. When I broke into the field, which was maybe mid-60s, let's say, many years ago, people didn't think in terms of how fast does something run. People were more interested in structure. So you'd say, is this problem expressible as a context-free language, say? Okay, now, that's very important when you're building a compiler. The context-free language is very important. But it's not what you pay for in general. The structure is not what you really pay for. What you pay for is the time it takes to run a program. And that was far from obvious, again, when I was a young man. The theory that built up around time complexity, just the idea that you can evaluate algorithms by their running time. How fast does it take? This led to, for example, theory of NP completeness, an intractable problem, and a huge, it was a huge breakthrough understanding what can a computer really do. That is, just because you can express the problem in formal terms doesn't mean you can actually write a program that will finish in any reasonable amount of time. Okay, that was, I think, a very big surprise and really changed the way we thought about computing. Let me mention maybe one more, one of my favorite things, is the relational model of data. Again, prior to Codd's paper in 1970, people tended to think of data in very arcane ways. I'm not going to go into these strange models. Relational model says, no, data is a two-dimensional table, so a logical view. And moreover, when you can query it either using first-order logic or a very simple algebra. And these ideas, of course, filtered into the SQL language, which is, despite the fact that nobody seems to like it, it has become really the fundamental language of database systems. And database systems, in turn, drive so many important applications. A company like Amazon essentially runs on a relational database. Okay. Anyway, I'm sure that there are lots more things that I'm missing, but maybe that's okay as a starter. Okay.
Yeah, that's very nice. Actually, we as we grew up and studied these two concepts, we took them for granted as if they were there. But the fact that they were not there, and at some point somebody had to think about these. And for example, when the Newton's laws were not there, somebody had to think about it and put them on paper. Similarly, like physics has evolved through these ups and downs. Computer science has evolved, and one of my favorite set of problems in time complexity were the recursive functions, and how do you do time complexity on those, right? So these were very amazing areas without which we won't be here. Google search won't be doing what it does in 300 milliseconds if we didn't have a notion of time complexity and indexing systems which evolved from database systems, right? So very true, sir. So the next thing I wanted to talk about, right? So this was kind of the historical view of how computer science had evolved. And I wanted to look at the future of computer science in the sense that now we are talking about data science more than computer science, right? Cognitive science, data science, AI. And in a way, the world of programming a computer to do something deterministically, knowingly what it will do, versus going to a next level and meta-programming it, if you will, and saying, I'm not going to tell you how to classify something. I'll just give you examples of inputs and outputs, and you have to figure out the classifier, right? And that transition is now what we are seeing in a big way in the last 10, 15 years. So how do you see this evolution from computer science thinking to data science thinking in students, for example? And you need a strong foundation of computers, but we also need to start evolving into this new way of thinking about data science. What are some of your thoughts, especially for the students who are looking at being future practitioners of computer science and data science, and how that journey will look like for them?
Okay. Well, first of all, I don't exactly see data science as replacing computer science. First of all, computer science really has always had two major branches. One you might consider systems, the other applications. Okay, so again, 50 years ago it was compilers and operating systems. Now it's networks and computer security and virtual reality. Virtual machines, which is not the same thing, of course. But the other branch is applications. Again, 50 years ago, that was study of sorting algorithms, maybe. But today, our ability to do applications has really made a lot of progress. So I don't see data science as an evolution of computer science, or I don't see it as a replacement. Let's say it's one of the things that the area of computer applications has become. So I see data science simply as applications of computer science to the sciences and maybe commerce. Okay. Artificial AI is another kind of computer application. Again, many people have a lot of trouble sort of saying, where's the boundary between AI and data science? I'm not sure there is a hard and fast boundary, but it seems that the AI people tend to be interested in more fundamental problems rather than applying it to a particular science. So an AI person might be looking at driverless car technology or robotics in general, or detecting detecting intrusions or language translation, things that have applications very, very broadly. Now, again, machine learning, I think you're really alluding when you talk about really machine learning has become a very big branch of computer applications. Okay, these techniques are very powerful, and they are used in both data science, let's say in astronomy to detect planets around stars 300 light years away. The same technology is used, in medicine to analyze CAT scans or imaging in general. And it's also used, for example, to detect network intrusions or really, or translate from one language to another. These are all, very beautiful applications. It's all very, very exciting.
Correct. Yeah, I think in my mind, when I grew up from computer science and I did my first project in, sort of AI, which was on genetic algorithm, that's when I got hooked to it and said, there is a very specific difference between the way we think in computer science versus things like optimization, things like statistics and all of that. And I think we need a very strong computer science foundation to actually also add to that these other kinds of thinking. And because computer science in my mind is a very deterministic framework, if you will. I know what I'm doing. I know I can code up an algorithm. It will have this kind of storage complexity, time complexity. And then when we reach the limit on that, then we depend on a lot of data and say now how I do it in a different way. Right? And like you said, these are very horizontal things. Like mathematics is a very horizontal field. It applies everywhere. Similarly, computer science is a very horizontal field, and data science is also very horizontal. And many applications are coming. Yes. So, sir, the next thing I wanted to talk about, right? So, in my mind, there are 5 great mysteries that we still don't know. One of them is what is intelligence, right? One of them is how the quantum world works. One of them is how the cosmos works. One of them is how the genomics works. One of them is even how the photosynthesis works. We all learn photosynthesis, but we still don't know how photosynthesis really works. So these are some of the great mysteries of modern times. And, our interest is in what is intelligence? How do we define intelligence? And is it just enough to mimic the behavior of human intelligence into machine intelligence? Or should we also be able to mimic the process in which the humans become intelligent? And similarly, the machines will become intelligent, right? With a lot of data and a lot of all of that. So what are your broad thoughts on, what is intelligence and how do we make intelligent machines? And are we on the right track with all the deep learning, machine learning that is going on? Is there a course correction required? Any broad thoughts you have around that, sir?
Oh, well, okay. Well, I'll talk about deep learning in a minute. But when it comes to intelligence, first of all, 25 years ago, I was a sort of a naysayer about artificial intelligence. I felt that it was fundamentally, the AI people were trying to mimic human reasoning and human behavior. And if you look back at it, it really didn't get us very far. Okay, it wasn't until you had the development of machine learning where you sort of saw the problem not as imitating human beings, but cool algorithms. And that's what enabled us to have all these marvelous breakthroughs. Machines now they effectively can see, they can understand speech and so on. All they play chess, they play Go, and beat us. but this is all done by algorithms, not by imitating human reasoning. I mean, it was, I remember 50 years ago, people saying, if we had to imitate birds in learning how to fly, then airplanes would flap their wings. And they don't. It's a completely different approach to get the same result. And I think that that's really what's why we're making so much progress now. That we're because we're not really trying to imitate human beings. We're trying to solve problems, and really smart people are coming up with really interesting approaches. I heard a statistic. I'm not sure whether it's true or not, but if you remember, Moore's law said that basically our computer power was doubling every year and a half or 2 years. Well, what I understand now is that these deep learning models, training deep learning models, whether you measure it in time to converge or numbers of parameters that you can handle in a model, that's doubling every 2.5 months.
Wow.
This is, I don't
Yes.
I don't know whether it's true or not, but I've seen some numbers that suggest something like that. So I don't think that we need a course correction. I think there's still lots of room for good, really innovative approaches. One of the problems, of course, is how do you create data? How do you create sufficient data? It's training. The bigger these models are, the more parameters they have, the more data you need, or else, you're doing what you call overfitting. You're basically just designing a network that recognizes your training examples and does nothing else. So I would not say course correction. I would say let's keep working. Well, lots of good problems and opportunities to advance in the directions that we're going.
Yeah, very much true, because I think there are different schools of thought here also, right? So I read this book on. It's a very interesting book for all data scientists to think about, the master algorithm by Pedro Domingos, where he talked about the 5 different tribes of how different people are approaching this field of intelligence. Some from the symbolic thinking, some from Bayesian thinking, some from statistical thinking, some from evolutionary thinking. And I think we are all converging towards the same kind of principles. And in a way, we kind of sort of know what it is, but we are trying to really figure this out and get it right. And definitely the evolution of GPUs and cloud-based GPUs and crunching and the next generation Moore's law that you talked about is really helping. And now I think it's a very interesting time for people to think about data science and choose a career in that area, because it has matured way beyond research. It is now in production in many, many systems, and there's still a long way to go. And that's how I see we are in the middle of the movie, if you will. We have a long way to go. So on that note, sir, I wanted to hear your thoughts on the fundamental skills that the students, computer science, data science, AI students have to develop, because what skill sets we needed 5 years ago, 10 years ago, and what we are going to need in the next 5 years, 10 years is also evolving, right? And the course curriculum, the way we teach, everything is going to evolve. So if you can just talk a little bit about, the fundamental skills that the students have to develop in today's era, what would they be, and how should we kind of, practice those skills and become more useful for the future of this whole field of computer science and AI?
Oh, well, let's see. Okay, first I'd say learn as much math as you can. Okay, the interesting thing is we've always, at least at Stanford, and I think most other schools, require calculus for any computer scientist. But we were doing that really more to torture them than for any purpose. Now, all of a sudden, with machine learning, you really need to know calculus.
Got
it. There are lots of topics in mathematics that will become, who knows what's going to become important, but mathematics is so fundamental, you really need to know it. Statistics is another area that I think everybody should know something about, every computer scientist. It's a little tricky. Statisticians tend to think of data science as a branch of statistics. It's not. Okay. On the other hand, statistics does keep coming up in design of algorithms of all sorts. For example, randomized algorithms, whether it's stochastic gradient descent now, and the machine learning people, if you think of, or there are primality tests and all. There are all kinds of interesting stochastic algorithms. But for example, I hope most people know what quicksort is. This is probably the first interesting example of a randomized algorithm. If you're not, you sort a list, pick a random element on the list, divide the list into the things that are lower than that element and things that are greater than that element, and then recursively sort the two pieces. Now, the interesting thing is, in the worst case, you'll always pick the lowest element, and it'll take you order n squared time to sort. That's not very good, but on average, it's really quite good. It's an n log n algorithm, like pretty much all sorting algorithms are, but it's the constant factor is pretty good. But in order to prove that, you need to know some statistics, because the fact that the average case is order n log n is far from obvious. Okay. And of course, a lot of the modern randomized algorithms are much more complicated than quicksort. I think, again, if you're interested in data science, I think you should start out by taking courses in basic algorithms and also database systems, which again there are just some very fundamental ideas. Everybody should know about databases and algorithms as a start. And then of course you're going to take some courses in machine learning, and I'd like to imagine that you will take some courses in applications that are application techniques that are not machine learning. For example, I'd like to talk about locality-sensitive hashing, clustering, association rules. These are all kinds of interesting things. And if you don't mind, let me just plug my book. Okay, it's you can get a free copy, and the URL is www.mmds.org. Not edu or and MMDS, mining of massive data sets. Yeah. And it's free. It's a free download. Covers a lot of data science, including machine learning, but also a lot of other things.
Yeah. I looked at I looked at the table of content. It's very comprehensive, and we were going to use it as one of the textbooks in our data science course coming up in GU Institute as well. So very nice compilation. Yes. The reason this question I pose, because I think the way our curriculums evolve, right, have to keep up with the fast pace at which technology is evolving. And when we were doing computer science, there were certain kinds of thinking that we had to develop, right? How do you think like a functional programming, or object-oriented thinking, or recursive thinking? So there are kinds of thought processes that we have to develop. It's not just finishing some courses and getting a grade. It's developing certain ways of thinking And like you said, database thinking is a type of thought process. And within that, there are SQL and NoSQL and graph databases and time series databases. There's a whole variety of it, right? Similarly, statistical thinking is a kind of thinking that we have to develop. And big data thinking is another kind of thinking, which is how do you break down a large data set into small chunks and solve each one, map reduce and all of that. So I see this field as a very beautiful collection of a variety of thought processes that the data scientists have to develop.
That's a very fair way of looking at it. Yes.
Yes. So very nice. Thank you, sir. Another question, a lot of this is on our minds, which is whether AI will be a redemptive force for humanity or it will be a destructive force for humanity, right? And we see movies of all kinds, and sometimes we see these, Schwarzenegger movies about destruction with AI robots coming from the future and all of that. And sometimes, Sundar Pichai talks about how AI is one of the most important things we have done, and it's as fundamental as electricity and fire. And there are both schools of thought. And I just wanted to hear from you where do you see the next 5-10 years of the future of AI, and whether it will be which side AI will take humanity on?
Yeah, well, I don't know. The Terminator movies, of course, are good fun, but I don't think that they really represent what's happening. I mean, if you look at what AI can accomplish, it's very good at limited tasks. It can beat you at Go. It can beat the world human champion at Go, but it can it can diagnose illnesses better than the best doctors. So, but we have made very little progress on a software that can set its own agenda. I mean, that's what Skynet, of course, in the Terminator movies was doing. It was basically it had its own purposes. We are really nowhere near that. And I don't think we're headed in that direction because there's no really good motivation to do that. And again, if you really are nervous about it, you say, well, it would be a terrible thing for us to do. But we're really not. We're not getting there. We're getting so many good results by looking at particular applications and using particular techniques to develop software that is really focused on, each piece of software is focused on one thing and does it often remarkably well.
So as far as, as long as AI remains what we call a specific AI, not a general AI, I think we still control what it does and how it does it. And so on that front, sir, when I see the history of technology in general, right? Like if you look at the nuclear power, for example, as a technology, the first use case of that was not nuclear power plants, but Nagasaki and Hiroshima, right? So when I look at internet as a great technology, you mentioned, the first use cases were not education. It's only after 20 years we are now using internet for education. Earlier use cases were all kinds of filth that goes on the internet and spam and this kind of stuff, fraud that happens versus. So in some sense, the way I look at this question is AI is more like a child and we are like the parent. And if we train the child to do the right things, it will do the right things when it grows up. But if we train it to do the wrong things, it will grow up doing the wrong things. The algorithm itself has no sense of morality, right? And you can say, hey, I want to put AI in a missile or a drone that can kill no matter what. It's not the problem of the algorithm or the technology, it's the person who created that, right? And today we are seeing things like deep fake and some of that. And this raises a very important question that one of the key skill sets that we need in data science and AI thinking is what we call AI in, ethics in AI. And this ethics part is becoming more and more important now, because with great powers come great responsibility kind of stuff. And AI is going to become a very great, powerful tool. We have only scratched the surface. the way I see the next few years. And I think as data scientists, one of the key value systems that we have to develop is to absolutely make sure that we don't cross a line, right? And this will happen all the time. In my own experience, this has happened many times. The line of privacy, how do we not cross? The line of not using the data for something else that it was not intended for, and not using AI for the destruction of mankind in some way. So I think it's a deliberate skill that we have to develop. It's a conscious decision we have to take everywhere as data scientists, that yes, it has the potential to do good and bad, and we have to make sure that our moral compass guides us, and not just the question which is, can we do it, versus we should ask, should we do it, right? That question is very important for all data scientists to think about. Okay? So great, Seth. So the next thing, before I let you go, is I wanted to hear your thoughts on the next year, the next decade, the next century, right? You are a thinker about, you've thought about computer science and brought us here. I don't know if you are a future person or a practical now person, but what are your thoughts on technology in general, computer science or AI in particular? Where are we going? What are some of the next use cases that will evolve, the next computational paradigms that will change this field, and some of the new ideas that will come? How do you see this field evolving? Because our people are very curious about what is my role going to be in this field in the next 20 years, right? So any thoughts on that, sir?
Yeah. Well, if I have a thought, it's that you can't have, you're a young person, you have no idea what you're going to be doing 20 years from now. I'm very often asked a question like this, what's going to happen, X years for some X. I don't know. If I knew, I'd be rich. Hey.
Correct.
But let me, I don't know if we have time, but let me just give you a little story that happened to me. It was March of 1992. And the date is important because at CERN, they were using the World Wide Web and HTTP, and they, which by the way was first used to support physics, not pornography, which is a counterexample to what you said, which by the way I do agree is kind of a reasonable generalization. But anyway, I was invited to a meeting in Washington, D.C. There were, I think, 300 people invited. It was a lot of academics and people from government and chief technology officers of major corporations. And we were supposed to predict the future of what was then called the information superhighway. I don't know, probably, since I assume this is before most of the people in the audience were born, you may not have even heard this term, but internet, was what it meant. And so we spent a couple of days debating issues, and the big issue was whether the cable companies or the telephone companies were going to carry the information superhighway. And we talked about protocols like Gopher and UUCP, Unix to Unix copy, FTP. None of the 300 people, myself included, had ever heard of HTTP, or the World Wide Web, and again, and these were, people who should have known better, and nobody did, even though it was out there.
Yes.
So, for this reason, I cannot answer your question. There's something that's out there that's going to change the world. I don't know what it is. You'll find out about it soon enough. Maybe you will invent it if you are lucky and in the right place, really smart.
Very true, sir. Very true. Very true. And, when I am asked that question, I respond exactly this way, that, 20 years ago, we would have not imagined having this conversation face to face, on an online world. And here we are, right? And therefore, by induction, 20 years from now, what is going to happen, we cannot imagine. But what you said, so something you said in the passing, which is very important. I think instead of worrying about that future, if we can participate in creating it, and it's only a few great people who transformed the world, right? The people who invented TCP/IP, the people who invented the laws of motion, the people who invented, VLSI or quantum thinking and all that. There are only a handful of people. It's not a statistical thing that on an average we will change the world. And I see them as mutations in our thought process. And I think, if some of us, we are like, I don't know how many are on the call, and even if 5 of us are here on the call who can, create that mutation in the world, right? What Tesla is doing and all of that. I think that is the kind of future that, we all hope to be, that our name is attached to something like the Dijkstra's algorithm, and now Google Maps is all over the place, right? So I think, that is
it
what
wasn't invented by Google, by the way, but that's okay.
Yes.
They bought the company.
Correct. Yes. Right. So yeah, I think instead of thinking about the future ahead, we should crave to create one. And thought leaders really can push the boundaries beyond average people. And I think that is the new skill that we need to develop as the next thought leaders, not just computer scientists or data scientists, right? Very true, sir. So just, on the final note, any other thoughts, anything that you want to talk to students about, inspire them about the future, whatever else, any parting thoughts before we
Okay,
close?
so you're lucky to be alive at this time. And it's a very, very exciting time. And I wish you all greatest success. Let me, though, suggest one thing. Okay, many of you will wind up doing what we might call research, whether it's a senior thesis or a doctorate, or you'll go to work for a company and you'll be given a problem to work on that requires some thought. There's a tendency that people have to sort of follow the herd. And what this means in the research context is you read the major papers in the field, and the papers they'll suggest an open problem, or they won't suggest an open problem, but you'll see what the paper's about, and you'll tweak the assumptions a little bit so you can write and invent something too. And then you'll write a paper about it. Maybe you'll leave some open problems. And, someone will come along and read your paper and work on your open problems or tweak your ideas. The trouble is, as this process goes on, you get further and further away from anything that's useful. The purpose becomes simply writing a paper and getting your name in print and published. And it's not easy, but there is a better way. And that is, you want to start from you want to start from a problem, something that it's either obvious that is needed, or most interesting, nobody realizes that they need it until they have it. And that's almost the hardest thing to do. Again, an old war story, xerography, copying, the technology for copying paper. The fact is, I think it was, I first met a Xerox machine in 1964. I remember, because this was I actually had a summer job, and just having access to this thing I can copy, it was just amazing. Before that, it was possible to copy, or make copies, but it was crazy. You had to actually people would take a photograph and print the photograph. Or you'd use, there were these mimeograph machines. I don't want to go into the technology, but it was crazy. You could run off copies. That's how they would, let's say, print a test. You'd type it on what's called a stencil, and then the stencil would produce copies. The whole thing was a mess. Anyway, IBM was apparently offered this technology. But they said, should we buy the patent? And so they went and they asked their clients. Again, at that time, IBM sold mimeograph machines, they basically, the answer was, well, we'd like it to be 10% faster and 10% cheaper.
Oh, okay.
Okay. And so IBM said, well, then this new technology isn't for us. Oh. And they walked away from it. And, so sometimes you have to, you can't just ask people what they want, because they don't know until you show it to them. And this is what the truly great people, not me, but the people who really have changed the world, this is what they do. They tell people what they need and they give it to them.
Wow, very nice. Very true. Yeah, very true. And yeah, very true. I'm sure people who were doing bullock carts never thought that they need a car. And then when they saw one, they said, yes, that's what I needed, right? So very true, sir. I think this has been an amazing conversation. We learned a lot, and I think our students will now look at the world differently, in the sense that how do we go problem first, discovering the right problem to work on, and then create a solution with technology, rather than saying, here is the hammers I have, let me find what the nails are, right? So working backwards is kind of a very interesting approach. And this is exactly one of the things we are also trying to do in Geo Institute, which is, instead of introducing students to algorithms and ideas, we are saying, let's introduce them to problems in industry and society of healthcare, agriculture, this and that. And then we are motivating them to say, therefore, you need to learn data science, clustering, and all of that, and work backwards from that. And I think that is a new way of teaching the modern sciences, which are very applied and practical. And thank you for sharing that insight, sir. Yeah. So thank you so much. And, I'm getting goosebumps that, I had a conversation with you, and, spending an hour with you is just amazing and very thrilling. So thank you for your time, sir. We learned a lot. Over to you, Bhavya.
Well, thank you, Dr. Kumar. Thank you. I think these are very, very interesting questions, and I hope that they actually got people thinking about perhaps their own answers to not just don't listen to me, right? Work it out yourself.
Yeah, Bhavya.
Okay. Thank you so much. Thank you so much, sir. It was indeed a pleasure for all of us here to grasp the beads of knowledge from the experts themselves. Now, our audience is quite passionate about this topic, and they have some questions for you, followed by a short interview by the Outreach Club. So shall we move towards them? Yes.
Yeah, go ahead. Go ahead.
Yes. So to Professor Ullman, you have been on both sides of the table, in the academia as well as in the industry. So what do you believe should be the steps taken by the academics to be industry ready and relevant?
Well, first of all, I spent a couple of, I think you're referring to the fact that I spent a couple of years at Bell Labs, but Bell Labs is really an academic institution. They just don't have the students. But we did exactly the same thing at Bell Labs that I did as a faculty member. And by the way, there are really no institutions like that anymore. Bell Labs was sort of a one-of-a-kind institution. I think, if you're teaching students the basics of, applications, whether it's algorithms or machine learning or any of these things, you're preparing them for a lot of industrial jobs. If you teach them, networking and computer security and cryptography and so on, you're also preparing them for many industrial jobs. Just coming back, to what I said about, when you pick a problem, pick something you want to work on, pick something that solves somebody's problem, rather than something that amuses you or that looks like some of the papers that you've read, or that, then you'll be well prepared. If you want to go out and work, you'll be well prepared to be a leader, I think.
Right, sir. Thank you so much. And to Dr. Shailesh, since you have been at the intersection of telecom and AI, what, according to you, is the role of AI in a telecom company like Jio?
Yeah, so, I work not just in telecom, but also refineries and healthcare and agriculture and many other sectors. But really, if I look at it high level, what does AI do to any vertical, right? What does it do? It increases what we call personalization of decisions, right? It makes the decisions more and more personalized. So on a particular day, right, how should the which coupon should go to which customer, or which movie should be recommended, or which course should a student learn, or which advisory should go to a farmer, right? So personalization of decisions is one of the themes, right? Optimization of operations is another thing, which is basically saying, how do I make sure my limited resources are well optimized? So whether it is supply chain optimization in retail, or, how do I do refinery manufacturing for the right outcomes? How do I optimize my operations, right? And overall, AI brings a lot of what we call efficiency in any system, because it does things very holistically. It does a joint optimization of many things which a human cannot do, right? And the third thing that we do is we think about adaptability as a theme. An intelligent system is ultimately very adaptive. And when I say adaptive, let me give an example in telecom. Today, if you look at telecom, there are fixed cell towers and there are antennas. And now think about, people are moving from morning to evening to commute and all that. The antennas cannot change, but the angles on the antennas can change and adapt to the demand patterns of the city. This is called a self-optimizing network, right? And that's the holy grail, for example, in telecom, which says, how do you know where to put the next cell tower? How do you know in which hour of the day, which cell tower, which antenna should be tilted at how much angle? How do you do demand forecasting and do this joint optimization? Because every grid is, under multiple cell towers. So there are beautiful, beautiful problems, which are not just machine learning problems, but there are outlier detection problems, recommendation problems, optimization problems, simulation problems, and adaptation problems, right? So the field of AI is very, very broad. It's not just what we learn in the classroom setting. And, I generally give a talk around that, which is the new architecture of AI and what the broad field of AI does. And in that, I talk about a lot of such examples that the next generation data science thinkers have to become what I call AI architects, who need to take a vertical and break it down into 200 individual APIs that are needed to solve the entire vertical, right? And that's a very important skill set to develop. How do we become system thinkers and solution thinkers, and not just model builders, right? And so the top down and the bottom up have to come together. And that is the kind of new skill set that we are going to need. And all these fields, telecom, retail, are filled with amazing problems. And the new fields like healthcare, agriculture, education is where the next 20 years of AI will be. And they are filled with even more amazing, problem statements, like Professor Ullman was saying. There are enough problems to find and solve for, whether it is in, environment and energy is one area, right? Water and purification and pollution and many, many areas are there. It's not just a banking job or a search engine job or a Facebook job. I think one of the things that, I urge my next generation data scientists to think about, open up your horizon to a lot of social problems in healthcare, agriculture, and you'll find amazing problems and you'll be challenged to solve them because there are no answers to them. We know how to build a search engine now, but we don't know how to build an adaptive telecom network yet, right? So how do we go from there to there? And that is where the future potential of all of you lies. Yeah? Thank you.
Sir, thank you so much. Like the algorithm in which you break down all these things, it was very insightful. So now moving on. Now this question is for both of you. Now, what words of encouragement and wisdom do you have for the budding minds present with us today?
Yes.
Well, enjoy being young. It doesn't last. I mean, it's, Shailesh, you have...
No, I think, yeah, please go ahead, sir. You want to add anything else? I can add, yeah. You've already talked about this, right? I mean, change the approach from solution to algorithms and all that. I will add a couple of things based on my own journey. I think becoming a first principle thinker is more important than very knowledgeable about a field, right? How do we become a first principle thinker? So if you want to solve a problem from scratch, how do we become that person using all the tools that we have learned, right? That skill is not taught explicitly. It is practiced over time. When you put yourself in a very hard situation of a very difficult problem, then the core skill is not what you know, but are you a first principle thinker? That's very important. Second thing I have learned is, Mr. Mukesh Ambani talks about the 3 Ps. He talks about passion, he talks about perseverance, and he talks about preparedness, right? So passion is, without that, I think we are not going to be able to solve a difficult problem today. We'll solve an easy problem that many others have solved. But if you look at the journey of Google for the last 20 years, or what Tesla is doing, or what Apple has done, or what Amazon has done, they are very perseverant about what they do. They don't give up easily, right? They keep looking for new ways of improving what they have built, right? And to all of you who are interested in doing a startup and solving a core problem, you're going to need perseverance. You're going to see ups and downs. VCs will not fund you sometimes. They will not understand what you're trying to do. I've been there, done that. And there are times when you are sort of, back and wondering whether you did the right thing or not. But I think if you really believe in what you're trying to do, and if you keep upskilling and reskilling yourself towards that goal, and if you remain perseverant, that's when $1 billion unicorn can be created, right? Like we are seeing a bunch of those coming out of India, and it requires a lot of those skills, right? So internal resilience is very important, right? And that is something we don't teach, but we have to develop, which says, I'll try this one more year and make sure, I'll put my best on this, good or bad, right? And let's not be too enamored by the success and failure ideas, but effort ideas. And I think resilience is what we need in our next generation innovators, because none of these things that the Einsteins and the Newtons of the world have invented happened just because they took a course and suddenly it happened, right? They thought about the same thing for the 20 years together, and then some, insight came. So that kind of mindset is now missing because we have a next job to do or a next salary upgrade to go to. I think we need to sort of think back and say, what is this, rat race doing to us, and kind of avoid that, solve a real problem, and that will be far more fulfilling than, having a lot of bank balance in your 60s, right? That's my take on this, and thank you so much for that question.
Thank you, sir. Thank you so much for your encouragement. Right. You two literally magnetized us towards the subject, and I believe the interest of our audience in computer science has now multiplied by many folds. Your insights will surely play a part in making the upcoming raw-minded generation in the optimum direction of development. So now I would like to invite Professor L.P. Singh, Dean of Student Affairs, IIT BHU, to deliver a vote of thanks.
Thank you, Bhavya. Greetings to everyone. I, on behalf of IIT BHU, once again heartily welcome you all in the opening ceremony of the 83rd edition of Technex'22, the annual Techno Management Fest of Indian Institute of Technology, BHU, Varanasi. Today with Professor Jeffrey Ullman and Dr. Shailesh Kumar, we indeed had a terrific start. It was an honor to gain insights on the future of artificial intelligence, machine learning, deep learning, data science, and many more topics relevant to studies of these students and their relevance in the industry from the two eminent experts in the field of itself. Team Technex and the students alumni interaction cell are immensely grateful to you both for galvanizing the contemporary minds with your cognizance and for all illuminating the stage of Technex'22 with your gracious presence. Thank you, sir, once again. I am also thankful to our Honorable Director, Professor P.K. Jain, for his gracious presence and sparing time in his busy schedules. Thank you, sir. I would also like to congratulate our meticulous students of IIT BHU Varanasi, who materialized this fest into its fascinating existence in the online mode for the second time. In spite of the prevalent conditions and restrictions, they sought to build the best out of whatever they had and bought Technex'22 LM. In this era of technological advancements, seeing Technex simulating into reality is an ecstatic moment for all of us. I wish all the organizers all the very best for the successful completion of this exhilarating fest and extend my wishes to the participants as well as who are looking forward to various talks and events in Technex'22. Once again, I extend a warm wave of gratitude to our esteemed guest, Professor Jeffrey Ullman and Dr. Shailesh Kumar, for obliging us with their visionary think talk, and to all the people who joined us for the ceremony. I wholeheartedly wish for the grand success of Technex'22. Thank you, sir.
Thank you.
Thank you.
Thank you.
Thank you, sir. Thank you.
Good.
Thank you, sir, for your heartfelt blessings and best wishes for the fest. Your motivating words truly fuel the wagon of Technex and propel its wheels forward. Now, on behalf of Team Technex, I would like to thank each one of you for being here today and witnessing the onset of the enchanting 83rd edition of Technex. We really hope you have a delightful experience with us while soaking your mind and soul in Asia's oldest technological extravaganza. In the coming days, wrap yourself around Technex because there's a lot yet to unfold that you would like to be a part of. So stay Technex and see you again. And I would like to request Professor Ullman and Dr. Kumar to stay for a while because we have some members from the Outreach Club of Film and Media Council to take a short personal interview of yours. That will hardly take any time. So, yeah.
Okay. Okay, so I'm just going to stay on. And,
Yes, sir. I guess we have the members from the Outreach Club over here in the Zoom call.
Yes, we are here.
Yes, you may proceed.
Thank you, Bhavya.